Hello, this video is about the introduction to slide bearing and lubrication. First, it's about the basic introduction. Bearings and lubricants are very common things in our lives. These items are used to transfer loads and reduce friction on contact surfaces. When relative motion occurs between surfaces, people usually add rings or lubricating oil between two objects in order to minimize friction and wear. It is worth mentioning that any insert that minimizes friction is a lubricant. The common lubricant in life is usually liquid, also can be solid, such as graphite, gas, or compressed air. In addition, as an oil, the liquid lubricant is characterized by its viscosity and other characteristics, while the lubricating oil has a name of some specific characteristics. So here are the two images about bearing and lubricating oil respectively. As a common lubricant, lubricating oil is very common in production and life. So, what is some properties of lubricating oil? The modern oil usually contain one or more additives. The PowerPoint depressant can make the oil flow at a lower temperature. The viscosity agent can ensure that its viscosity will not change too much as the temperature changes. The foamer can prevent foaming when the machine is running at a high speed. Oxidation inhibitor can ensure no oxidation at high temperature. Corrosion inhibitors have similar functions. They can prevent metal surface corrosion. Detergents and dispersants are used to minimize the formation of engine deposits. The anti-wear additive is usually solid, which is conductive to reducing friction and wear. Grease is a liquid lubricant that is second to provide special properties. When lubricating, oil is required to be kept in a proper position. Lubricating grease is usually used, especially when frequent lubrication is difficult or costly. At the same time, grease can also prevent harmful pollutants from entering between bearing surfaces. It should be noted that grease cannot circulate, so it has a cooling and cleaning functions. Then it's about the sliding bearing type. Plain bearings requires that the bearing member slides directly on its support. They are different from rolling element bearings that insert balls or rollers between sliding surfaces. There are two types of plain bearings. Number one is journal bearing or sleeve bearing, which is cylindrical and supports radial load. Second is a thrust bearing, usually plain bearing, supports axial load. Plain bearings, usually thin shells that are easy to replace, provide bearing surfaces of suitable materials, such as babbitt or bronze. Sliding bearings can also be split into one-piece cylindrical shells called bushings. And here are more examples of sliding bearings. There are three types of lubrication. Figure A shows the load journal bearing at rest. The bearing clearance is full of oil, but the load has squeezed out the oil film at the bottom. Slow clockwise rotation of the shaft will cause it to roll to the right, as shown in image B. Continuous slow rotation will cause the shaft to remain in this position. This is boundary lubrication. In image C, if the shaft speed increases, pressure will be generated and the shaft will float. Under appropriate conditions, the minimum film thickness H0 is reached. This is hydrodynamic lubrication. And here we can see the image about the journal bearing that I mentioned before. In this image, it's about hydrodynamic lubrication. There are three things that should be mentioned in the hydrodynamic lubrication, especially in the calculate part. It's about the viscosity mu, rotating speed n, and bearing unit load p. In order to achieve a hydrodynamic lubrication, it is necessary to have number 1, relative movement of the surface, number 2, wedging action, and number 3, presence of a suitable fluid. The engine crankshaft only turns slowly when the crank is turning, and then the load is small because there is no combustion load. Once an engine is started, combustion will greatly increase the bearing load, but the speed will increase enough to establish hydrodynamic lubrication. Peak combustion load has instantaneous duration, and inertia and transient squeeze film effect prevent oil film from being squeezed. That's all for today's introduction, and thank you for watching.